Scientific notation. We use scientific notation because it makes large and small numbers very easy to use. The general rule for this class is you will always use scientific notation when the number is greater than 1,000 or smaller than 1,000. When we are talking about scientific notation in chemistry class, we are talking about proper scientific notation. Proper scientific notation consists of the first part in which there is only one digit to the left of the decimal, so the number must equal to 1 or greater than 1 or less than 10. And it has a second part in which is times 10 to some exponent or power. As noted in the previous slide, proper scientific notation always has one digit left of the decimal. So if I have an example such as 9.3 times 10 to the fourth, this is proper scientific notation because we have the decimal here and there's one digit to the left of the decimal. If we have a number such as 37.00 times 10 to the negative third, this is not proper scientific notation because left of the decimal there are two digits. If I have a number that's 0.011 times 10 to the seventh, this example is also improper scientific notation because there is no digit to the left of the decimal. That digit must equal to 1 or greater than 1 or less than 10. Write the following in proper scientific notation. So if we look at number 1, which is 4010, this number has an unwritten decimal. The unwritten decimal is to the right of the last zero. To write proper scientific notation, we must have one digit to the left of the decimal. Right now we have 4 digits, so I need to move the decimal at least 3 times to have one digit before the decimal. So if I write this is 4.01 times 10. We move the decimal 3 times, so my exponent is 3. It is a positive exponent because it's a large number. Large numbers have positive exponent. Small numbers have negative exponent. Pause the video, try number 2 and 3, and then check your answer. For number 2, the unwritten decimal again is at the end, right of the zero. To write proper scientific notation, I need one digit before the decimal. To get that, I need to move the decimal to the left until I have one digit left of the decimal. So that's going to be 3.7 times 10. And I move that 1, 2, 3, 4, 5. So my exponent is to the fifth, and it's positive because it's a large number. On number 3, the decimal is provided for you, but this is not proper, so I need to move the decimal to the left until I have one digit to the left of the decimal. 1, 2. So my answer becomes 2.7103 times 10. I moved it twice. It is a 2, and it's positive because it's a large number. For number 4, we have 0.00200. In order to write it in proper scientific notation, I need to move the decimal until I have one digit to the left of the decimal. Here I must move it to the right. 1, 2, 3. When I do that, I have 2.00 times 10 to the third because I moved the decimal 3 times. Since this is a small number, I need to include a negative. It has a negative exponent. So pause the video, try 5 and 6 on your own, and then check your answer. For 5, we have 0.000004. Again, I have to move the decimal to the right to get a digit in front of the decimal. So when I do that, I have 4 times 10. I move the decimal 1, 2, 3, 4, 5, 6. Since it's a small number, it becomes a negative 6 as my exponent. And number 6, the decimal is given. I need to move it to the right to make a proper scientific notation. When I move it 1, it's going to be 1.1 times 10. Since I moved it 1, my exponent is 1. And since it's a small number, it is a negative exponent. So 1.1 times 10 to the negative first. Writing proper scientific notation. For large numbers, we move the decimal to the left until we have 1 digit to the left of the decimal. For small numbers, we move the decimal to the right until there is 1 digit left of the decimal. Pause the video. Write the following into proper scientific notation. Some are already written in scientific notation, but they are not proper. And then check your answers. If you can't do these problems in your head, the easiest way to solve these is to break them into parts. So we have 32.00 times 10 to the 4th. The first thing you're going to do is you're going to ignore the exponent, and you're going to take this first part of the number and write it into proper scientific notation. To do that, we're going to locate the decimal, which is given right here, and we're going to move it until we have 1 digit left of the decimal. That means I have to move this to the left. So when I do that, this becomes 3.200 times 10 to the first. Because this is a big number, it's going to have a positive exponent, and I moved the decimal once. Now we have 3.200 times 10 to the first, which is also multiplied by 10 to the 4th because that was given. In math, when we multiply exponents, we add them. So this becomes 3.200 times 10 to the 5th. Exponent of 4 and a 1 adds to the 5th. So on number 2, we're going to do the same thing. We're going to ignore the exponent given. We're going to write the first part into proper scientific notation. To do that, we need to locate the decimal, and we need to move it to the left here to have 1 digit to the left of the decimal. When I do that, I have a number of 1.00100 times 10 to the 3rd, positive, because it's a large number. This is also multiplied by 10 to the negative 7th. So we're going to rewrite the first part of the scientific notation, and when we multiply exponent, we add a negative 7 plus a positive 3 gives you 10 to the negative 4th. So for number 3, we have 0.00300 times 10 to the 3rd. Again, we're going to ignore the exponent. We're going to write the first number in proper scientific notation. Since this number is really small, we know we have to move the decimal to the right until there's 1 digit to the left of the decimal. So that's going to be 3.00 times 10 to the 3rd. We moved it 3 times. Since it's a small number, it's a negative exponent. Times 10 to the 3rd times 10 to the negative 3. When we multiply it, we add the exponent. So this becomes 3.00 times 10 to the 0. 10 to the negative 3rd plus a positive 3 becomes 0, and 10 to the 0, you guys know, is equal to 1. So this is just 3.00. Number 4, we have 0.10140 times 10 to the negative 5th. So the first thing I'm going to do is look at the first part and write it to proper scientific notation by moving the decimal to the right 1 place. So this becomes 1.0140 times 10 to the negative 1st. This is also multiplied by 10 to the negative 5th, When I multiply exponents, the exponents add, so this becomes 1.0140 times 10 to the negative 6. A negative 1 plus a negative 5 becomes negative 6. The first thing you want to do is make the first part of the number into proper scientific notation. Afterwards, the exponents are multiplied, so that means you are just going to add the powers. Pause the video and write the proper scientific notation for the following, and then check your answer. Number 1, we have 93,040. In this one, we have an unwritten decimal at the end of the number. Since this is a large number, we're going to move the decimal to the left until we have one digit to the left of the decimal. So this becomes 9.304 times 10. We move the decimal 4 times, so the exponent is 4. Since it's a large number, it is a positive exponent. In number 2, this is a small number, so we're going to locate the decimal and we're going to move it to the right until we have one digit prior to the decimal. This is 7.430 times 10 to the third, because we moved it 3 times. And since it's a small number, it is a negative exponent. So times 10 to the negative third. In number 3, again, we locate the decimal. The decimal is going to be moved to the right once to have one digit to the left of the decimal. So this becomes 1.4 times 10 to the first, because we moved the decimal once, and it's going to be a negative number because it's a small number. On number 4, we're going to locate the decimal, which is here. We're going to move the decimal to the left to get one digit to the left of the decimal. So this becomes 1.43 times 10 to the 1. And it's a positive 1 because it's a large number. On number 5, again, if you can't do this in your head, look at the first part of the number and write that into scientific notation. 300 has an unwritten decimal at the end, so we need to move this decimal to the left for proper scientific notation. This becomes 3.00 times 10 to the positive 2 because it's a large number. This is also multiplied by 10 to the negative 11th, so that means that we need to add the decimals. So this becomes 3.00 times 10 to the negative 9. A negative 11 plus a positive 2 is a negative 9. So for number 6, again, we're going to write the first part in proper scientific notation by locating the decimal, which is given right here. We're going to move the decimal to the right to get one digit prior. So this is going to be 4.567 times 10 to the second power because we moved the decimal twice. Since it's a small number, it's going to be a minus 2 times 10 to the negative 2 times 10 to the negative 5th. We must add the exponents. So this becomes times 10 to the negative 7th. So my answer is 4.567 times 10 to the negative 7th. On number 7, we locate the decimal. Since this is a large number, I need to move to the left to get one digit to the left of the decimal. So this becomes 9.7300 times 10 to the second because we moved the decimal twice, and it's positive because it's a large number. On number 8, we're going to locate the decimal, and this is going to be moved to the right. We're going to continue moving 1, 2, 3, 4 times until we get one digit to the left of the decimal times 10 to the negative 4th power because we moved the decimal 4 times, and this is a small number, so it's a negative exponent. On number 9, we're going to convert the first part into proper scientific notation by ignoring the second part. Locate the decimal. We're going to move this to the right. 1, 2, 3. So this is going to be 1.00300 times 10 to the 3. Because we moved the decimal 3 times, it's a positive 3. And since it's times 10 to the third, and we have another times 10 to the third, this actually becomes 10 to the sixth. We add powers when exponents are multiplied. On number 10, we're going to change the first part into proper scientific notation. We locate the decimal. We're going to move it to the left twice. So this is going to be 3.11300 times 10 to the positive 2 because it's a large number. This is also multiplied by 10 to the 6th power. So that means we have to add this. So my power now becomes to the 8th. 6 plus 2 is 8. So this is my final answer. So what you want to do is locate the decimal. And you want to move into the direction in which we have one digit to the left of the decimal. The exponents are positive if it's large number, negative for small numbers. Now we're going to do the opposite. We're going to take proper scientific notation or scientific notation, write it in written form or expanded form. So written form or expanded form is another way of stating write out the scientific notation. Write the following to expanded form. For number 1, we have 103 times 10 to the 2. I look at the first part of the number, which is 103. I locate the decimal, which is not given, so it must be located after the last digit, which is 3. Since it has a positive exponent, which is times 10 to the positive 2, I know the number is big, so I need to move the decimal to the right 2 places. 1, 2. Remember, the exponent tells you how many times you move the decimal. Now in these spaces, we must add zeros as placeholders. So now my answer is 10,300. For number 2, we have 1.11 times 10 to the negative 5th. So the first thing I do is I locate the decimal. Since it's a negative exponent, I know the number is small. Therefore, I need to move the decimal to the left. 1.11. I'm going to move to the left 5 times. 1, 2, 3, 4, 5. All these empty spaces, I must add zeros as placeholder. The decimal here is at the left side. We're going to rewrite the answer to clean it up. So 0.0000111 is your final answer. Pause the video and try 3 and 4 and then check your answer. So number 3, we have 7.77 times 10 to the positive 4. We rewrite it. Decimal is given right here. Since the exponent is positive, the number is big, so we need to move the decimal to the right 4 times. 1, 2, 3, 4. All these places that have empty spaces, we must add zeros as placeholder. So you need to rewrite the answer to clean it up. It's 77,700. Number 4, again, we're going to rewrite this. We're going to locate the decimal. The decimal is given right here. Since my exponent is negative, it's going to be a small number. I need to move the decimal to the left 3 times. 1, 2, 3. My answer becomes 0.66600. One comment I would like to make. If you notice, sometimes I include zeros at the end. So when we are expanding scientific notation, whenever the exponent is positive, we move the decimal to the right. Anytime the exponent is negative, we move the decimal to the left. Just think it through. Just notice a positive exponent means the number is really large. A negative exponent, the number is really small. And you move in the direction appropriate. Pause the video, try these problems on your own, and then check your answer. So you're going to write the following into standard form. So number 1, we have 8.0 times 10 to the 4th. Positive exponent tells you that this is a large number. So we need to move the decimal to the right. Decimal is given. So I'm going to start and move to the right 4 times. 1, 2, 3, 4. Every place there is empty space, I must add a 0 as a placeholder. So now I need to rewrite the answer. So this is 80,000. On number 2, we have 39.430 times 10 to the 5th. This is a positive exponent, so we know it's going to be a large number, and we need to move the decimal to the right 5 times. So if I locate the decimal, it is given to you, and I need to move it 5 times. 1, 2, 3, 4, 5. All the empty spaces, we must add zeros. I'm going to rewrite it to clean it up. And so it's going to be 394,300. So my answer is going to be 3,943,000. On number 3, we have 1.5 times 10 to the negative 6. Since this is a negative exponent, I know my number is small. I need to move the decimal to the left. So I locate the decimal, which is between the 1 and the 5, and I'm going to move it 6 times. 1, 2, 3, 4, 5, 6. And every place there is empty space, I'm going to put a 0 as a placeholder. I'm going to rewrite this. It's going to have 5 zeros and then a 1 and a 5. That's my final answer. So number 4, we have 66.43 times 10 to the negative 2. Negative 2 tells you the number is really small, so I need to move the decimal to the left 2 times. So it's going to be 1, 2. I'm going to rewrite the answer. So 0.6643. On number 5, we have 3.7 times 10 to the negative 5th. Negative exponent tells you it's a small number. We're going to move the decimal to the left 5 times. 1, 2, 3, 4, 5. Every single time there's an empty space, we add zeros as placeholders. And you need to rewrite it to clean it up. And this is my final answer, 0.000037. So for number 6, we have 9,000 times 10 to the 3. So we look at the first part. 9,000 has an unwritten decimal at the end. So we're going to move it to the right because it's a positive exponent 3 times. 1, 2, 3. All those empty spaces will be filled with zeros, which are placeholder. If I rewrite the answer, it becomes 9 million. On number 7, we have a negative exponent. A negative exponent tells you I need to have a smaller number, so I'm going to move to the left 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All these places will have zeros as placeholder. So we're going to clean it up and rewrite it. So it's going to be a point. It's going to have 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 6, 3, 4 is my final answer. On number 8, again, this is a negative exponent. So we're going to locate the decimal. And we're going to move to the left to make a smaller number. 1, 2, 3. All these places need placeholders. I'm going to rewrite it to clean it up. 0.005550. And number 9, it has a positive exponent. So I know it's going to be a large number. I need to move to the right 6 times. I located a decimal. 1, 2, 3, 4, 5, 6. I rewrite it. It becomes 900. In the last problem, it has a positive exponent. We locate the decimal. I'm going to rewrite it down here. And we're going to move it 7 times. 1, 2, 3, 4, 5, 6, 7. All these places that don't have a number, we put zeros as placeholder. So my final answer becomes 40,000. So writing scientific notation into standard form, we just do the opposite of what we did when we did proper scientific notation. When the exponent is positive, we move to the right because we want a larger number. If the exponent is negative, We move to the left because we want a smaller number. Just look at the sign for the exponent, locate your decimal, and move accordingly.